Okay, so I'll be solving the question for this one in a minute. So this was the question that was given. So there are 5 different countries, that is V, W, X, and then Y, and we have the last one as Z. So we'll go one by one. Like it is said that there are 2 countries. The first statement says all countries are having different national animal except 2. That is, 2 countries will be having same national animal. 2 countries has same national animal. Okay. So and then later it is said that Y country has tiger as the national animal. Y country has tiger. Country, and then we'll have national animal. Okay, so this, as I said, this is a direct hint. You are already given the information regarding the Y country. Let's say we already know that Y has a tiger as national animal. Now let's go to the third statement. As I said in the first statement, there are 2 countries which have the same national animal. Now let's come to the third statement. It says W and X are having the same national animal, which is not wolf. So we found that W, comma X are the 2 countries that have the same national animal. But it is not wolf. So, and also the animals that are left are tiger is done. So we are left with cat, deer, wolf. And then, as it said, for country in the last statement, Z does not have deer as its national animal. Okay, this I said, as I said, this is an indirect hint. You're not going to make any conclusion at the moment, but at the end it will be very useful. So let's go to the final statement. Let's say it says neither a deer nor a cat is the national animal of the country V. So we have the statement where we are left with 3 animals that are left, that is cat, deer, and wolf. So since it is said that the deer is not the national animal, and even the cat is not the national animal for V, so we are only left with wolf. So based on this statement, we got that wolf is the national animal of V. Okay, and the question says which country has wolf as a national animal? The answer is V, option 3. So is this clear to everyone till now? Any doubts? And now we'll solve and complete the complete configuration. Now what does it say? W and X are having the same animal, and we are done with wolf. So we are only left with cat and deer. As it said, Z country does not have deer as its national animal. So even deer isn't possible for Z. So the only thing that is left is cat. Cat for this. And we are only left with deer. Deer for the 2 countries which have the same national animal. So it becomes deer for both of them. Deer. And so this is the final configuration for this, and you will be asked like 3 to 4 questions based on these type of questions. So please try to be attentive. And This is just an easy example of this. The questions will be getting tougher as you go by. So try to understand how this is going, and you have to just make sure that you understand what the statement is. And you have to first start with what are the direct hints. As I mentioned, you will be already given information regarding it, so it will be easy. Like here you can see it is said that Y country has tiger as national animal. You already got one element for Y, and even this last statement and the others are all indirect hints, but we made some conclusions at the end because of all these indirect hints. Okay, so if any doubt in this question. Okay. Okay, so I'll be explaining it once again. Like you can see over here, the first one, there are 5 countries: V, W, X, and Z. And then the first state animal, as it says, all countries are having different national animals. Countries has the same national animal. And next, right? And you'll be later. We got the. Okay, so we'll go to the next question. And I'll be showing the next question. You can try for some time, and we'll start the next one. So, and now we'll go to the next question. That is again a simple one, and later we'll increase the toughness of the questions. And I'll be showing you the questions. Give me a minute. Okay, take question number 30 down. We'll start solving this. So the screen is visible to everyone, right? You will be given 4 questions based on each passage. So it is very important to try solving this and find what is the easy way to do this. And as I said, this is one of the most important topics in the exam that you are going to give. So please try to focus. and there might be some key errors in this, like the answers can be wrong for some of the questions. So as I'll be discussing them, please try to focus so that we can correct which are wrong in the uh, PDF that I am sharing right now. We'll be sharing this PDF to your faculty or someone. Don't worry about that. We'll be discussing the questions. As I said, there are some issues with answers in for some of the questions. So just on the class, don't worry about the PDF. Okay. So I'll be discussing the solution for this one. So good for all those who have solved the question. So now the screen is visible to everyone, right? Or is there any issue now too? Okay, so try to take a screenshot or something of this. I'll be starting to discuss in 2 minutes. Or if you want, you can take it down. We'll start solving this. It is it is B that was there. B did his task in 20 minutes. It is not 8. There is some mistake with the typing or somewhere or the printing that was given in the question. So it is B did his task in 20 minutes, not 8. So if any other questions, you can type it down in the chat box regarding the question or any issue with the question. As I said, there are some wrong in the key, and even the questions there is some typing mistakes. So please try to listen to the class to know where there is a issue, so that you won't be having any issue while if you get the same question in the exam, you should be able to solve it so easily. Okay, so I'll be start solving the problem. Okay, this is the question that was given. Now we have total 7 people, A, and then we have B, then we have C, and we have D, E, F, and G. So let's go statement by statement. After the first thing that was given, it is said that C did the washing. So this is the name of the person, name, and then later we have the tasks that they were doing, task, and we have the duration of the task. So we'll be having it over here. Now it is said that C did the washing. So for C, the task is washing. Okay, and it is said that A did the cooking. The second statement says A did cooking. So, and again, we'll come to this statement again. It says D neither did mopping nor dusting. So this is an indirect hint. So we need some time, or later we'll be using this. So we don't have much use of it at the moment. And the next statement says B did his task in 20 minutes. So the duration of doing his task for B is 20 minutes. And now later, F did his task in 22 minutes. So here, F, it is 22 minutes. Okay. So now it is said that G neither did cleaning nor sweeping. Till here, it is an indirect hint. Now it says, but completed the task in 29 minutes. So for G, the duration of the task is 29 minutes. Okay, and we are done with A, we got the task, C, we got the task, and the durations for B, F, and G. So, and later, what is there? The statement, it says the time taken by E, the time taken by E is to complete the task was more than D. So, E is greater than D, and but less than the time taken than C. So this is the order that we are going to have. That is, it is said that the time taken by E to complete the task was more than D, but less than the time taken by C. So this is going to be the order for this. And now the statement says, the next statement says, the time taken for cooking is greater than time taken for vacuuming. As it said, the one who did vacuuming took less time to complete than the task than the time who did cooking. So cooking is greater than vacuuming. This is the case we have for now. And later we'll go to the next statement. It is said that dusting was not one of the first 3 tasks done. Okay, we'll come back to this again. And the one task that was done in 25 minutes was neither cleaning nor vacuuming. So this is again an indirect hint. F either did cleaning or mopping. So even this is an indirect hint. We'll come back to this again. Now this statement will be very useful to us. The one who did vacuuming did the task in 29 minutes. We already know that G did the task in 29 minutes. So G did the task for G is vacuuming. And so we found that for vacuuming, the time is 29 minutes. That is. So since this is 29 minutes, this is 29 minutes. The time from the times we know it is 20, 22, 25, 26, 27, and 29 and 30 minutes. So there is only one case possible for cooking to be greater than this. That is, the 30 minutes should be the time for cooking. So, A, the duration of cooking is 30 minutes. So, till now, is everything clear to everyone or any doubts? Okay. So, I'll be going forward regarding this. Now, we are left with only three times, that is C, D, and E. What are the remaining times that are left? We are done with 20, 22. So, we are left with 25. The time is 25 minutes is left, and 26 minutes is left, and the third one is 27 minutes. So we are left with these three timings. So for this equality or the inequality to be possible, the only possible case is C has to be 27 minutes, E has to be 26 minutes, and D has to be 25 minutes. Okay, so is this clear to everyone? So C is 27, E is 26, and D is 25 minutes. So, okay, till now it's fine for everyone, right? Or any doubt till now? Okay, so let's go forward for this question. Now, the question says, who did his task in 26 minutes is the question. And we know what are the timings for each of them. So, the task which was done in 26 minutes was E. So the option is the answer is option 4, which is E. So you can see over here. Now let's go and solve the complete configuration so that there will be three more questions. I'll be showing it to you one by one so that it will be easy and how you can find how it is so easy to solve these kind of problems. And later. Now let's come to the indirect statements that were given to us. Now we have completely four that are left. That is B is left, D is left, next E is left. We don't know the task of E, and then we don't know the task of F. Okay, and what are the tasks that are left for us? That is, one is mopping. Okay, so this is mopping, and then cleaning is left. Cleaning. Okay, so and again dusting and sweeping are left. So these are the four tasks left: dusting, and again sweeping over here. Sweeping. So we are left with these four tasks for the four different persons that are over here. So now let's go to the statements one by one. Okay. What does the statement say? D did not do mopping or dusting. So for D, he didn't do mopping or dusting. This is also not possible. Okay. So he is left with cleaning and sweeping. We'll come back to this again. Now, G, we already know that G is doing vacuuming. So this G neither did cleaning nor sweeping statement is not of much use to us. So and then this was the other statements that were given were for us to find the timings for that. And now dusting was not one of the first three tasks done. What are the first three tasks that are done? The first three tasks that are done are B 20 minutes, that is smallest one, and then 22 minutes, and then 25 minutes. So for dusting, we can't have B, D, and F. Okay, so is it clear to everyone? Dusting was not one of the first three tasks done. So it means that it wasn't the first three fastest ones to complete. So till now, is it clear to everyone? So we are left with, since all the three are wrong, we are only left with E for dusting. Okay. So since E is done for everything, so E can't be cleaning and E can't be mopping since E is already assigned with dusting. So E can't be sweeping too. So for E, it is dusting. Control C. Yes, it can't be. It is said that cleaning, not sweeping. That means it is not doing both cleaning or sweeping. Because also we already know from this statement that was given over here, that is the one who did vacuuming did the task in 29 minutes. We all from the previous statement that was given over here, G neither did cleaning nor sweeping but completed the task in 29 minutes. So we have assigned, we know that G time is 29 minutes. And from this statement that was given over here, the one who did vacuuming did the task in 29 minutes. This is the second statement. And the other statement was G neither did cleaning nor sweeping, but completed the task in 29 minutes. So this is going to be the order for this. Okay, so the one who has asked the route, is it clear? Okay, now we are done with E. And so we are now left with four others, that is B and B, D, and F. Now let's go to the next one. What does it say? The one task that was done in 25 minutes was neither cleaning nor vacuuming. So what was the task that was done in 25 minutes? 25 minutes was D. You can see over here, 25 minutes is D. So for D, it is neither cleaning nor sweeping. So cleaning is gone. So we are left with D. We are only left with sweeping for D. D is sweeping. Okay. So is it clear to everyone till now? So since sweeping is already taken, these two also can't have sweeping, and B and F can't have sweeping. So now we are only left with mopping and cleaning. So the statement says F either did cleaning or mopping. This statement that is over here, F either did cleaning or mopping. So let me first copy this over here. This is sweep. Okay, I have already copied. Now we are only left with mopping and cleaning. So let's go forward. That is, it is said that F has either done mopping or cleaning. So this statement we already know based on this. So because only two spaces are left for F. So it has to be one of these two. We don't have much use from this statement. So the one who did the cleaning did not do it in 20 minutes. So let's check what was the 20 minutes one. That is B. So B did not do the cleaning from the statement. That is, B is also not doing the cleaning. So F has to do the cleaning, and B has to do the mopping, and there is nothing left with over here. Now let's just complete the configuration. So for B, it is mopping. And for E, it is cleaning. Sorry, for F, it is cleaning. So this is the final configuration for this one, and we'll check the remaining questions that were there. I'll share the complete screen right now. Was the one? F is, it is not neither. It is either cleaning or mopping. Just check the question again. It is either cleaning or mopping. It is not neither. Just check the question again. Either means at least one of them has to be true for F. Neither means both of them are false. Okay, so is it the configuration is clear to everyone or any doubts regarding this? So I'll be showing the question for this. The other questions on this, we can try solving or checking over it. Hello. So the other questions that were given on this was the one that was given. So the which of the following combinations is correct? It says first is D sweeping, E vacuuming, B cleaning, and F mopping. So we'll check one by one. Uh, so we found that D is sweeping. So it is the correct answer. As I said, there is some issue with the key. So just change it. The answer for this is option 1. It is not option 4. So this is wrong. The option 1 is correct. The vacuuming is for G, and cleaning, we know that cleaning is for F. So, and even F, we know that F is for cleaning. So the answer is option 1. And the last question that we are going so this is what we know. Which task took the longest time to complete? We know that cooking is the longest time that has taken to complete. So, so the answer is option 1 here, that is cooking. And the last question that is there from this is, what was the time taken to complete the washing? Washing, we know that the time taken was 27 minutes. So the answer is option 3. You'll be having questions of this kind as I have solved. This is a very important topic, as I said. You'll be having 3 to 4 questions on each of the passages that you are given. So don't go first based on the indirect hints, as I said. First, try to list down all the direct hints that you have, as I said, like you're having C did the washing, A did the cooking, and D completed his task in 25 minutes, and these kind of statements. So if you get these kind of statements, you can directly at least have part or half of the configuration done, and later based on the, okay, you want to show me the configuration. Okay, I'll show it. So please take this down, image or something of this. Give me a minute. I'll just erase all these lines. So take this image or something. I'll be going to the next question after this. We'll be doing one more puzzle, which will be a bit easier compared to this. Everyone has taken down this configuration, or do I have to wait for some more time? The one who has asked to show me the answer, Praveen. Have you taken it down? Okay, I'll be next going to the one more puzzle. I'll be showing it to you in some time. Uh, try taking this question down. We'll solve it in some time. I'll be giving you 5 minutes if you want to solve this question, or else you can type it in the chat box and tell me if you have got it, or else I'll start the question solution for the question. Okay, so even this is done. Okay, I'll be going to a different question. Sorry, as I discussed before, this was already shown. Okay, give me a minute. Okay, so everyone can see the screen. Is this question done? Okay, try taking it down. I'll start solving this after some time. So everyone has taken down the screenshot or something of this question. Okay, so there are five friends. That is the name. We'll just take name, and then later we have the experience of them. Experience, and then later we have their manager. One is the role of them. Okay, so this is what we have. So, okay, let's go statement by statement. It is said that Ben, the first guy, let's write one by one. That is, the first one is Alex. Okay, and now the second one is Ben. Ben. Okay, and now the third one is. Okay, so some of you are already saying that this is already done. Is it already done or a new one for everyone? Please tell me so that I can try a new question. Okay. Okay, anyway, I'll be discussing this, so don't worry. To all those who have listened it before, just try to see it again. So the third one is Charlie, and now we have the fourth one, that is Dan. And the fifth one is Ellie. So these are the five guys that are working in a different departments at a company. Now let's go to the hints. They are working and they are reporting to different managers with the name Sarah, Jane, Mike, Amelia, and Sam, and all of them have experience from 1 to 5. So now let's go one by one. It is said that Ben has been at the company for 3 years. So Ben is 3. The experience of Ben is 3. And then the next one is, it is said that he reports to Amelia. So the manager of Ben is Amelia. Okay, and we don't know what his role, but it is said that he is not a programmer. So let's leave this for now and we'll come back to it again. Now, the designer reports to Mike and has been at the company for 4 years. So, 4, and then the manager is Mike for this guy. And he's been a designer. Based on the second statement, this is what we understand. Okay, so now let's go to the third statement. It says the programmer has been at the company for 2 years and he reports to Jane, and he is a programmer. Okay, now the third one. Charlie has been at the company for 1 year. Charlie, she has been at the company for 1 year and she reports to Sarah, as said in the fourth statement, Sarah. Okay, now the third one is, the next statement is, Alex is a creator and has been at the company for 5 years. This is 5 and he is a creator. Okay, so we are only left with 2 and 4. That is what we have over here. Now let's come to the statement that are given in the next one. It is said that Dan is a programmer. So since Dan is a programmer, we already know the programmer reports to Jane and has an experience of 2. So we can completely take this configuration and paste it over here. This 2 comes to over here and Jane comes over here and programmer also comes over here. This is the configuration for Dan. As we got that Dan is a program. And it is said that the next statement the developer has been in the company for 3 years. We know that Ben is working in the company for 3 years. So he has been a developer. Okay. Now since 4 is on the left, 4 the lady has to have experience of 4 years, and she has to report to Mike, and her role is a designer. So since all of the managers are done, the only manager that is left is Sam. So Alex has to report to Sam. Okay, and since only analyst is left over here, Charlie has been an analyst. So this is the final answer. Let me get it down so that we will solve the 4 questions that are based on this. We'll go to the questions that are there. Okay. Now I will be showing the questions. Okay. So this says which of the following combinations of person, job title and manager is correct. The first option is Dan, programmer and Sam. Dan is a programmer but he doesn't report to Sam. He reports to Jane. So the first option is wrong. And the second one is Alex designer and Sam. Alex is a creator. So the second option is also wrong. The third is Ben, a programmer and Amelia. Ben is not a programmer, he is a developer. So the third option is also wrong. So the answer for this is so everyone can see this right? I have already told you to take an image of this. So we find that the option 4 is the correct one for this, and then we'll go to the next question that is there on the same one. Which of the following person manager is correct? So there are 4 options, that is Charlie and Amelia. Charlie reports to Sarah, so the first option is wrong. And the second one is Ellie Jane. Ellie reports to Mike, so the second option is also wrong. The third one is Alex and Sam. So Alex reports to Sam, that is the correct option that is there. Fourth is Dan reports to Jane, so it is wrong. The fourth option is also wrong. So the answer for this is option 3, that is Alex Sam. Now we have one more question. What is the role of Ben in the company? The role of Ben is developer. So the answer is option 1. So these are the questions that are based on this. So everything is clear in this question? Or any doubts you can ask me so I can just look it over again, and or else we'll move to a new topic. This topic is called syllogisms. This is one of the most important topics. As I said, like you might have seen these type of questions in many different types of exams. Like even this is important for competitive exams too, if you are going to give it in the future. So please try to understand the theory first. We'll be solving some questions later. So as I said, the syllogisms, the statements are some A are B, all A are B, no A are B, some A are not B. These are the most common kind of statements that you are going to see. So to solve these kind of questions, you need to make sure you use the help of a Venn diagram, because it is the best way to solve these kind of questions, and it helps us very much in making the conclusions. Since you will be given just the statements of this kind, I will show you some questions that were there in this. So this was one of the questions that was there. So it says some museums are stadiums, and then some stadiums are auditoriums, and then all halls are auditoriums. You have to make the conclusions at the end based on all the four conclusions. You have to check which of them are correct. So you'll be having like around 3 to 4 questions minimum from these kinds. So please try to concentrate on this. Now I'll be discussing how the Venn diagrams will be there for this one. So as I said, this is the common Venn diagram for some ARB. That is, you'll have a small intersection over here. That is, this is B, and you're having a small contact at this point. There is a small intersection over here, and this A is a part of B. So you can say that even this diagram also works. And this part of A, that is the outer part, is not B, but this part is A. And even if you take the completely equal part that is over here, even this comes under some A or B. I'll explain you what the primary and the secondary diagrams are. So, and the second one is all A or B. So this is the primary diagram that we'll be taking. That is, the inside part will be A and the outer part will be B, as you can see in the Venn diagram over here. And the complete portion A equals to B also works for all A or B. And then the third one is no A or B. There is no intersection between them. That is, there is a gap between them, and they should not contact anywhere. And the fourth statement is some A are not B. Like you can see over here, this part is A or B, some A or B, but this part should not be B. That is over here, that is not B. So even this works, and then no A or B also works because you have some of the part of A that is not B. And even this is, as you can see, this outer part is A. This outer part that is there over here, this part, that is not B. So even this diagram works. Now, uh, what is the primary diagram and what is its use? Now I'll just draw and show you a flowchart to you. And this is the final type of ways that you're gonna do on this. So let's start with something like that. So you'll be given a statement, and then later there are two types of statements in this. One is a positive statement. Positive statement. Now, what is a positive statement? You might have this doubt. A positive statement is a one which contains no or not in the sentence. Like you can see, some and all are positive statement. Like I'll type it down over here. Some, comma, all. Okay, only it shouldn't contain any not or no. Okay, now there is one more type, that is the negative statement. The negative statement. So it contains no, comma, some, not, these kind of statements in them. So these two are the statements that are possible. So let's say this is the first kind of statement and this is the second kind of statement. Now, for positive statements, you are going to make conclusion just based on primary diagram. And what is the primary diagram? You might have this doubt now. A primary diagram is the one which has the minimum intersection. Like you can see, there is only a small part of intersection over here with the other one. And here there is a complete intersection or it is inside the B. And also here, you're making sure that the two items are having a large amount of intersection. So this is the one that is the primary diagram for this sum ARB. Similarly, you can see that for all ARB, this is completely immersed in it. So this has a minimum intersection. So as I said, this is the primary diagram, and I'll show how we'll be drawing the primary diagram for these kind of statements, and then later for negative statements, we'll first check. There are again two types in negative statement. That is, if you contain no and not. The first is check the conclusion based on primary diagram. Okay. So this for this is one. So you'll be getting a true or false directly based on this for this one. Either it will be a true or a false. You don't have to do anything for this. But for the negative case, you'll have two cases. One, if the conclusion is true. The second case, if the conclusion is false. Okay. Now, if the conclusion is false, in this case, that is the negative statement based on the primary diagram, if it is false, it remains false. It remains false. But if the conclusion is true, you will have to check. You'll have to take the opposite of the statement. Let's say opposite of the statement and use the help of secondary diagram and make sure make decision of this opposite statement, opposite conclusion or statement. Okay. So if this statement comes true, if after this, if we get the statement as true, the opposite statement is true, opposite statement is true, the final conclusion will be false. It will be giving a false. As you know, if the opposite is true, the one that is opposite to it has to be false. And now we have one more conclusion. Now if the opposite statement is also false in all cases, opposite statement is false, then it is true. Okay, so now till now is everything clear to everyone? This is an important theory. So please try to ask doubts. Don't try to hesitate because this is an important topic. As I said, you can type in the chat box. I'll try to explain it again. Okay, now as I said, there are two types of statements. You will be given the statements or you will have to make the conclusion. Let's say statements or conclusions. You'll be given and you'll have to find if the statement is true or false. So you have this statement. Let's say I'll just give an example of this. So for all ARB and all BRC, you'll have a Venn diagram of this sort. Like as we know, A will be inside and B will be outside. So this will be the Venn diagram for this one. All ARB and then all BRC. And now let's come to the second one. That is all ARB and some BRC. Now, as I said, a primary diagram is the one which has a minimum intersection. So we know that this is the primary diagram for all ARB. And now you might ask, since some BRC, you can even have this Venn diagram of this sort. As I said, there should be minimum intersection. So you don't have any proof or something that says that A and C are intersecting. So, like for example, I know many of you watch cricket. So let's say there is this thing called inconclusive evidence or something when there is a catch grounded, and some of you who are watching might feel that is out, and some of you might feel it is not out. But the final decision will be made based on the decision that was given by the on-field umpire. So as I said, you don't have any conclusion over here. That is some BRC. For some BRC, there is no intersection between A and C. So we take the primary diagram this way. As I said, the primary diagram statement says it has a minimum intersection, which is the umpire decision, as I said before for cricket. And the some BRC is a statement which you have to prove later. The umpire will be giving it out if he has given it out, else it is not out. So and now if you are given this way, all ARB and some ARC. So here you are given a statement that some ARC. So you can even have it this way, like you can have complete C inside. Like as I said, there should be minimum intersection between them. That is only some part of C will be intersecting with B and not lying completely inside. And similarly for some ARB and some BRC, this is A and this is B and this is C. So you shouldn't have it this way and have the Venn diagram over here, so that there will be minimum intersection between all the three Venn diagrams. So and finally, this is the one. Like you are having all ARB and all ARC. Now this is A and this is B and C will be somewhere just coinciding with this, so that it comes like this. This is C, this is A and this is B. This is the way we have the minimum intersection. So till now, everyone understood how we get the minimum intersection thing, so that I can explain how the statement and the flowchart that I have drawn. Is there any doubt for the primary diagram? Okay. So since this is clear to everyone, I'll just explain what this flowchart is right now, so that it will be easy for you to understand. Now, the statements, as I said, the statements are, you will be having some ARB, ARB, and then the other statement is all ARB, all A are B. So now these are the positive statements. Okay. Now the last one. The second one is negative statements. For this, the statements are no A or B, and then we have some A are not B. Okay. So this is what the positive and negative statement says. So these are the kinds, most common kinds. There will be some more. I'll be explaining them at the end, and also there will be a what they say. Since you do something, there will be some anomalies somewhere over there. I'll be even explaining those, how to solve those. Now, as I said, the two types of statements there are: positive statement and a negative statement. Now you will be given a different questions, like as I have shown before, this Hall's auditoriums question. You will be first drawing the primary diagram, what is over here. Let's say all A are B and some B are C. You will be given a primary diagram for this. That is, this is the primary diagram. Let's type it and I'll be showing it to you. This is the primary diagram. Okay. So now, after this, as I said, if the statement is positive, now let's say the conclusion that was given, I'll copy this completely and I'll explain it with an example. Okay, I'll just type in the question again. So the statements that were given before are all A are B and then some B are C. Some B are C. Okay. And now the conclusions that we have to show if they are true or false. Conclusions. Let's say you have uh, all ARC and then no ARC. These are the two conclusions that you have to show. Now we'll draw the diagram. Let's say this is A, this is A, and now we'll draw B. This is B. And then since you know all A are B, this is the primary diagram for it. Now we have some BRC statement. That is this. This is C. Let's just change the color. Okay. So this is the diagram for this. Now what does the first statement say? All A are C. Is there any intersection between A and C? No, right? No intersection. So the first conclusion is wrong. The first conclusion is wrong. So as I said, this is the primary diagram for this. Primary diagram. Okay. So how did we come to the conclusion on this? Since all ARC is a positive statement, as I have shown in the flowchart, we'll make the conclusion just based on the primary diagram. There is no contact between these two. So this conclusion has to be wrong, as you have over here. That is, I'll just copy this and show you. This first conclusion is all ARC. This is a positive statement. And then we have drawn this is the primary diagram that is there over here. This is the primary diagram. And then we have checked if there is a contact between both of these. And so there is no contact, or we can't say that all ARC. So we finally come to a conclusion that it is false. Okay, so till now, is it clear? Now I'll explain how we do the negative statement. Till now, is there any doubt? Now, okay. Now we have the negative statement, that is no A or C. Okay, so now what do we check? First, we check conclusion based on the primary diagram. What is the conclusion that we get? It is said that, okay, let's copy it over here. So, and we'll show it one by one. What was the conclusion that we have got from the no ARC? It is that there is no contact between both of them. What does it make it? The conclusion based on the primary diagram is true. So if this is true, we'll go this way. That is, the conclusion is true. Since if it is false, like if we already have a Venn diagram of this sort, and the statement was no ARC, you already have a conclusion that from the primary diagram that there is a small intersection between A and C. But in this case, there is no intersection between both of these two. So it is of this sort. So now we'll go to this part of the flowchart. Now, second conclusion, it is true. So it comes over here. It comes over here from here to here. And then now we have to use the opposite statement. Now, what is the opposite statement for no and some or not? I'll be typing. Just make a note. No ARB. The opposite statement is some A or B. Now let's say if you prove some A or B in any diagram, the opposite statement, that is no A or B, is obviously false. Is it true or not? This is the statement and this is the opposite. Okay. So now there is one more statement, as we know, some A are not B. For this, the opposite statement is all A are B. Okay. So take this down. I'll be, no, this is just a normal example. Don't take this. This is like a no ARB. This is just, I'm explaining it right now. This is not related to the question that I have been solving. So don't worry. It can be B. This is just the theory. I wanted you guys to take it down to know what the opposite of a statement is. Take this down. You'll be having a lot of questions on this. So you have to understand what the opposite statement is when I ask or try to explain to you. So now we know what now we are at this part of the flowchart. Now we'll be coming to this. What is the opposite statement for no ARC? We know that it is some ARC is the opposite statement. Now we have to check if there is any diagram possible where there is a small intersection between A and C. That is what is the secondary diagram. As I said, primary is the one which has the least intersection. But secondary, you don't have any such rules for that. So you can move any of your diagrams and make sure that all the statements that are over here, that is all ARB and some BRC, are coming true. So now this C that was over here, I have just moved it to over here. So now what does it become? There is a small intersection between A and C over here. This is A and this is C. There is a small intersection. So we proved that opposite statement is true based on the secondary diagram. This is true. So now, as I mentioned, even this statement becomes false. So now, is it clear or any doubt? I'll explain it again if you haven't understood it. Okay, everyone is clear for everyone? Okay, I'll explain it again, so don't worry. So as I said, For positive statements, we'll only make conclusions based on the primary diagram. As you can see, all ARC is the first statement that we have taken. And further, the primary diagram, as I have mentioned over here, it is the one which has minimum intersection. Okay, so we try to not have any contact between A and C for this. We will have this way. Now, for negative statement, so this is no ARC statement. We'll first check the conclusions based on the primary diagram. That is no ARC. There is no contact between A and C at this place. There is a gap between these two and they don't have any intersection. So now, later, so this statement we have found that it is true, though no ARC based on the primary diagram. Now what I have said, we use the opposite of the statement. That is, we check if some A or C is true or not. Okay, this is what I have written over here. As I have mentioned, this is the statement and this is the opposite for it. I have mentioned it in a box. Please try to note it. If it will be very useful in many of the questions that you will be solving. And then later. So now this is the primary diagram. I'll just copy it again so that you guys don't get confused. Okay, now we have to check if some A is C or C is possible or not. So what I am going to do is just move the diagram that was over here to just inside this way. Okay, so now there is a small intersection between A and C. As I said in this statement, opposite of the statement should be used, and we use the help of a secondary diagram. As I said, the secondary diagram is the one which doesn't have any rules for intersection or anything. The primary diagram has that rule. That is the reason we have drawn it this way. That is, we didn't intersect these two, or else we can draw it this way too. This becomes the secondary diagram, but this is the primary one. Okay, so now after this, we found that based on this secondary diagram, there is a the statement, the opposite statement is true. If the opposite is true, the one statement that is opposite to it, that is, if some ARC is true, the opposite statement, that is no ARB, should be false, and vice versa. Like if it is false, the opposite statement no ARB becomes true. Okay, so is it clear now? One who has asked to explain, Sheikh Asif Pasha. Is it clear or should I go again? Okay, now I'll be just solving a small problem on this. I'll be first showing it to you. You guys start solving it. I'll be later telling you how to solve these kind of problems. Okay, just give me a minute. I'll be sharing the screen again. Okay, so the screen is visible to everyone, right? So this statement, the conclusions, every conclusion contains positive statements. So don't worry, you don't have to do any secondary diagram for this. So I'll be going one by one. Just try to solve this. I'll explain it in few minutes. Good. So many of you have solved this, how to do this, and I'll explain it now why it is the option 2 or why it is correct. Okay, now let's take this question, that is, okay. So now we have the first statement is some printers are laptops. So this is one, and the other one is this. Let's change the color. Okay, this is the printer. This is the laptop. And now we have one more, that is all laptops are computers is the second statement that we have. Okay, this is the computer. Why I have drawn it this way, because we have to have the minimum intersection, as I have said before. This is the computer, and the last one that we have is some tablets are computers. So we'll have one more over here, that is a small intersection with it, and it is L. This is a tablet. Okay, now you can see that all of these are positive statements. That is, the conclusions are also positive. So what is the first conclusion? First one is some computers are printers. So is there any intersection between computers and printers? Yes. This part, there is a small intersection between computer and printer. So the statement 1 is correct. The conclusion 1 is correct. Conclusion 1 is correct. Why? As you can see, there is a small intersection between computers and printers. And now the second one. What is the conclusion? It says some tablets are printers. We can see that there is no intersection between printers and tablets. So conclusion 2 is false. Okay. So now third one. Some tablets are laptops. Again, we can see there is no common intersection between these two. So even this statement is false. Conclusion 3 is false. Okay, and now the last one, that is some computers are tablets. We know that there is an intersection between these two. So the conclusion 4 is true. Okay, so the conclusions 1 and 4 follow. So is there any doubt in this question? As I said, for a positive statement, we only check the primary diagram. We don't have to go anywhere and try checking the. If you have any doubts, you can stop me here, because the toughness of the questions will be increasing. Please try to clear your doubts right away. Okay, now let's go to the next question that contains a negative statement and a positive statement. Please take it down. I'll be sharing the screen. The take down question number 1 and try solving it. 3 again. Like as I said, sorry, what was the one that you explained? Sir, conclusion 3 again. Conclusion 3, it is direct. Like for positive statements, as you have taken the flowchart, there is no contact between white and rats. So it is false. There is no contact anywhere. As I said, for a positive statement, you only have to go make the conclusion based on the primary diagram itself. Who was the one that has asked me? Praveen? Okay. Why concluding true or false? We need to compare with question. Okay. So let's say you are given a statement. Hmm, some ARB and some BRC you are given. And let's say you are trying to do a secondary diagram as you wish, but you are not following the rules that are given in the question. Let's say you are given all rats are cows and no cows is white. If the statements are given, those have to be followed for sure. The conclusions are the one you don't have if they are true or not. So if the statements, what are the statements given? All rats are cows and no cow is white. You have to follow them at any cost in secondary diagram or a primary diagram and make sure that these two are not violated while you are trying to change the primary diagram to a secondary diagram. As I said, we can try to have an intersection between these two, but you are violating the second one. That is, you are getting the white inside the cows, but the second statement says no cow is white. So this secondary diagram is wrong. Okay. Okay, who was which none of the above follows? No. Okay, so is everything clear to everyone, or anyone still has a doubt? Can't we place rats partially outside cows? Okay, who was that was asking the question? So can you explain conclusion 2? Okay, so as I said, the conclusion 2, it is a negative statement. The no white is rat. And then later we checked if there is a contact between white and rat. There is no contact. So this is based on the primary diagram. It is true. Like you have the flow chart as I have sent in the chat. I'll be sending it again if you haven't taken down. Okay, so next. After that, we have the opposite statement that says, for no white, I have discussed before, for no, we use some as the opposite statement. So the opposite statement is some white are rat. Now we try to prove if there is a possible case in a secondary diagram that we can have an intersection between rat and white. If we try to bring it over here, we are violating the second rule, that is no cow is white. So you can't bring it inside or even just try to have a small intersection with this because the cows, none of the cows is a white. It is given the statement. So you shouldn't violate the statements that are given in the initial statements, the first two. Okay. Conclusion 4 might be true. Okay, as I said, for a positive statement, you have to just make the decision based on the primary diagram. You shouldn't check the secondary diagram. Okay, conclusion 4 is a positive statement. It contains all. And as I said, all cows are rats is wrong because some of the cows outside the rat, that is this part of cows, is not rats, this outside part. So you should not, this statement becomes false because some part of cows outside the rats are not rats. Okay, so is it clear to everyone? Okay, now let's solve one more problem on, I'll try to show some balls are not, some are not questions so that it will be easy for you. Okay, take down this question, question 12. I'll be solving this in some time. Try doing this. This is the sum or not. As I mentioned, for sum or not, the opposite statement is all are. And I'll be sharing that too. Don't worry. I'll share the question. Give me a minute. Try taking this question down. The paints putty question. I'll start solving it after some time. Okay, I'll be explaining the question in some time. Please give me a minute. Okay, I'll start the solution. I'll be sharing the screen now. Okay, this was the question that was given. Now first let's draw the primary diagram for this. This is the paint. And next we have the putty. Putty. And next it says some putty or paste. And later it says no paste or tapes. Tapes. So this is the primary diagram that we have chosen to draw. So is it clear to everyone till now? Okay, now let's go conclusion one by one. Now, what are the positive statements that are given 1 and 4? Let's first check 1 and 4. What are the first conclusion? Some paint or paste. Okay. So this one we have, this is the conclusion one, and this is a positive statement. And is it true or false based on the primary diagram? That is, there is no intersection between both of them. So this is false based on primary diagram. Okay, so it remains false since it is a positive statement. This is conclusion one. Conclusion one. Okay, now we have the second one. Okay, let's go to the fourth one. That is again conclusion 4. That is some paste or putty. Okay, this is again a positive statement. And there is a small intersection between paint and paste. Sorry, paste and putty over here. So this statement is true. This statement is true based. This statement is true based on primary diagram. Okay, so till now with the positive statements, is there any issue for anyone? Okay, now let's come to the negative statements that are there. What is the negative statement? That is conclusion 2. What does it say? Some tapes are not putty. Okay, so now you have some tapes that are not putty. As you can see in the primary, you can have it working in a secondary diagram or a primary diagram. There is no intersection between these two, and so none of the tapes are putty. So this conclusion works true based on primary diagram. Now we have a next statement. Now, since this is based on a negative statement, and since this is a negative statement, as you know from the flowchart, we have to first check if it is negative or positive. Then, since this is true, we take the opposite statement. Opposite statement is, I have shared it in the chat before to opposite. So it has to be all tapes are putty. Okay, so this is the opposite statement that is going to be there for this statement. Now we take this primary diagram, we'll copy this completely. So as I said, this is the primary diagram. Okay, so now for this, we'll check if all tapes are putty is possible or not. Let's just try to move this into here, into putty, and have no connection with paste. There is no connection with the paste. So now we can check that all of the statements are being followed. That is the initial statements that were given. What are all the initial statements? All paints are putty is working. Some putty or paste is working, and no tapes or paste is also working. So this secondary diagram is valid. So this is a secondary diagram. Okay. So now the opposite statement. We tried to prove that this statement is true based on the secondary diagram. True based on secondary diagram. The opposite statement is true. Don't get confused. Opposite statement is true based on secondary diagram. Now what happens if the secondary diagram makes sure the opposite statement is true? The negative statement that was there before this statement becomes false. Okay, so is this clear? Any doubts? Okay, now let's go to the next one. That is no paints or tapes. We have no paints or tapes. And then now we'll check if the paints and tapes, are there any intersection between both of them? In the primary diagram, there is no intersection between paints and tapes. So this is true based on primary diagram. And as I mentioned, this is a negative statement again. You have the flowchart before that I have shown you. This is a negative statement. And then now after this, we try to take the opposite statement. What is opposite statement for no? It is some. Opposite statement is some paint or tapes. Okay. Now we again take the primary diagram that was there over here. This was the primary diagram that we had. Okay, now what do we have to prove? We have to prove that there is a possible case where paints and tapes can intersect. Now let's say we take these tapes over here and have an intersection, and there is a possible case for this, like you're not having an intersection with paste and tapes, and there is an intersection between paint and tapes. So you're making sure all the statements that were given in the question is being followed, and there is an intersection between paints and tapes. So this statement becomes the opposite statement becomes true based on secondary diagram. And now if this is true, what happens to this? This statement becomes false. So as we have seen, only conclusion 4 follows. That is option 4. Like there is, as I have said, there is some issue with the key. So don't just try to follow the key that is over here. Now, is there any question on this? So this will be the last one I'll be discussing today. So this is conclusion 3. And this is conclusion 2. Okay, what were there are some questions in the chat. Let me just check it. Let's display the question. Okay. This is the question. No, like as I have mentioned, you are saying some are not. You are trying to prove if you are saying you can take the opposite statement as some tapes are putty is what you are thinking. Is it, Abhishek? So in that case, what you are trying to prove is you are trying to again show the same. Like if I just take tapes are putty, some tapes are putty, you're again proving that that statement is true. Like you won't be having any impact on that, because if you prove some only some of the A or B, you're already showing that some A are not B. That is the statement again. It won't be the opposite of it. Like if you show, let's say you have a room filled with A and B. Now if I show all the A that will be inside the room, and the room will be outside, that is the B. And one more statement is what you are saying is there is a and some intersection with B. So I'll show it with an example of a Venn diagram. So this is A, and let's take one more. This is B. Now, if you are taking some A or B, this is the diagram again, the primary diagram. So you are already showing it again. This statement becomes the same. That is some A or not B. It won't be the opposite for some A or not B. Okay. Is it clear, Abhishek? Some A or B automatically indicates that some A are not B. So it won't be the opposite for it. We use opposite because if that becomes true, the opposite has to become false. Only conclusion 4 follows is the final answer. Okay, someone asked, please explain option 3 again. Okay, what was the one that was there? Okay, sir, based on opposite statement. Yes, you have to draw for every opposite statement and make sure the negative statements, the opposite statement, you have to try it through. You can have as many diagrams as possible. If the conclusions are 100 and there are like 50 negative conclusions in that, you have to draw 50 different secondary diagrams and make sure they are not true in any case. The opposite statement is not true in any case, so that only then the opposite statement, that is no or some or not statement, will be true. As someone asked, the answer is only conclusion 4 follows. Okay, so any more questions? The session is done. If anyone has any doubt, they can ask, the others can leave. Try typing it in the mic. Just type it in the chat. I'll be giving the mic option if you want. Please show the question once. Okay, give me a minute. The answer is option 4. There is a typing mistake over here, and the answer is option 4. And in option 4, it is only conclusion 4 follows. You don't have to do all of this in 1 minute, because like in theory, like networking and all these types of sections, you won't be taking much time for you to answer those. Like you'll have good amount of time to solve these kind of questions, because for puzzles and syllogisms, as I have said, these are the most important topics in this. You have to try practicing this, try searching for syllogisms, and even in any CAT or any competitive exam, you can see a lot of questions based on this. So just try practicing before the next session I'll take. They said no pains active. They said no pace are tapes, not no paints are tapes. It isn't paints. It is pace, the statement that was given in the question. Please check it again. I have shown the question. No paste are tapes, not no paints. Okay, any other question you can ask, else you can leave. Thanks for being for the session. The final answer is only conclusion 4 follows. There is 2 more topics that I'll be discussing in this, so don't worry. I'll explain. There is one more case where it says either or case is there, and if you find either or case, don't worry. There will be some questions based on it. Will we get possibility type question? Possibility is just that now we are possibility is you are making sure using the secondary diagram is the possibility. That is what possibility means. Like if you use a secondary diagram and make sure all the statements given in the question are followed, it is just a possibility. That's it. You don't have to worry much about possibility questions. You will be given questions on possibility. Like let's say now you are given this way. This was a question that was given. Now is some paints are tapes, is it a possibility or not? If they ask, now what are you going to do? You're just going to take these paints and tapes over here. That's it. It is possible. So the answer is it follows. That's it. If they ask it is a possibility, it means you have to Just make sure you draw a secondary diagram and check. That's it. Is it clear for the one who has asked the possibility question? You can have as many secondary diagrams as possible. It isn't a problem. You have to just check the status of the opposite statement, if it is true or not. You can draw in what way you want. Like as I said, I have drawn it this way. You can even take it inside and place it over here, or even you can increase the size of it and draw this way. Anyway, you can have as many secondary diagrams as possible. It isn't the issue, but you have to just check the check if the opposite statement is true or not. That's it. Okay, is there any different approach? There is, the approach isn't different. I'll explain it why the questions are different for either or case, because in that there will be two opposite statements given in the conclusions. There is some tricks like income expense. Okay. Even that is fine. The income expense method that you are talking is fine, but as I said, you'll be having to draw these secondary diagrams even for that. And also it is a bit complex compared to this, because you can draw these secondary diagrams very easily if you try practicing some questions. And as I said, there is in that income expense questions, okay, only few is same as some or not statement. Okay, I was going to discuss it in the next class. Don't worry. I'll be explaining everything regarding this topic, as this topic is very important. Only few is same as some or not statement, because you're saying that only a few of these. It is similar to, there is some of the items are not B. It is similar to some or not. Okay, if I suggest this method personally. If you are free to learn the income expense, it is not a issue. But as I say, this is easy because you can draw as many diagrams as you want in a short amount of time. Because if you understand the theory for this, you can draw as many secondary diagrams as you want, but only for negative statements, as I mentioned in the flowchart. Okay, any more questions? Else we can end the session. Okay, as I said, the probability is just that you have to use the secondary diagram. That's it. Possibility, as I said, possibility or probability is a question which makes, like, you have any case possible where there is some intersection between both of these two. Like, if, as I have said in this, you are able to see my screen, right? The ones who have asked these questions. Yes. So I'll be showing, let's say you are given a conclusion saying some tapes are paint is a possibility. Okay, this is what was given. So, but our initial diagram was this. This was the primary diagram that we had. Now we have to check if this is possible or not. Now, possibility indicates you can make use of a secondary diagram. Okay, so we just try to move this over here, and there is no contact between tapes and paste, and it works. So this possibility is true. Okay, so the one who has asked regarding the possibility question. Okay, yes, as I said, for negative statements or no or not, the one who has asked the question, we have to prove chance. You can take any secondary diagram and try to prove that the opposite statement is true or false, and then check if the status of the initial statement, that is no A or B. We check the opposite statement, some A or B, and then conclude the final if it is true or not. Is it clear, or any more doubts? You can ask, else others can leave. Any other question? Please type it in the chat box, or else I'll be ending the session in 5 minutes. I don't know regarding the PDF. I'll be letting you know in the next session, because we haven't yet talked to your college regarding this. Okay. The conclusion 4 doesn't follow from the secondary diagram. It is a positive statement, and it only is the conclusion is made based on primary diagram itself. Okay, I'll explain the possibility diagrams in the next session. Don't worry. Possibility is just that you have any one diagram or a secondary diagram where it is true. That's it. There is nothing much issue in that. You'll be able to understand it. So don't worry. Okay. There is one more question that is coming. Okay, as I said, the primary diagram is only for positive statements. The secondary diagram should be used for negative statements. That's it. Try to learn this. You don't have to worry much about this. As I said, the complementary pair type questions is you have, as I have mentioned, I'll be discussing it in the next session. Don't worry. And there is one more question that was asked. So there is possibility of paste in paint. Paste in paint. Okay, so it's possible. So what was your question? Kadir, what was your question? I didn't get your question. Okay, so there is one more question. So does some paint include? As I said, if there is just the possibility is given at the end, then you have to make sure you use the secondary diagram for a positive statement. If there is no possibility attached at the end, you have to just make use of the primary diagram itself. Okay, I got your question now, Kadir. So, as I said, for a positive statement which doesn't contain possibility at the end, you have to just check the primary diagram itself. You shouldn't make any changes to the primary diagram. Okay, is it clear? Okay, again, what was your question? Sir, does some paste include paint also? No, as I said, this Sagarika, it doesn't have any intersection in the primary diagram, as I have shown to you. There is no contact between these two unless in the secondary diagram you can make some changes to this. But in the primary diagram, as I have mentioned before in the theory, that there should be a primary diagram is the one which has minimum intersection, as I have mentioned over here. Okay, is it clear? Any more questions? Any other questions you can ask, else I'll be ending the session in 5 minutes. Okay, thank you. Thank you everyone. You can leave the session is done. I'll be closing it in 2 minutes. If anyone has any issue, you can type it in the chat box, please. Either or, I'll be explaining it in the next class. It is just that two opposite statements will be given to a conclusion. So if you try, let's say you're given some ARB and no ARB. If you try taking the secondary diagram help and try to do no ARB is also false. In that case, you're trying to prove that some ARB is true in that, like as I have mentioned. Like we have A and then B and then C. This is C. This is C. And this is A. Now these are the this was the initial diagram. Now the conclusion that are given are some ARC and no ARC. Which was given. Let's say both of them are opposite. So what do you have? You have to know that at least one of them has to be true. Now since from the primary diagram, some in the first statement it is a positive statement, so it has to be false. There is no intersection. Now the second is a negative statement. It is true based on primary diagram. True based on primary diagram. And then later we will try to make use of the opposite statement, which is again some ARC. Now for this we use the help of secondary diagram. So we will try to do that some ARC is true. And again then the statement becomes false. So that shouldn't be the case. So at least one of them has to be true. In that case we use either or because. Is it clear? Okay. So the thank you everyone.